Hello, assalamu alaikum everyone. Welcome to Shophair Academy. Okay, so the paper we're going to go through today is for physics, and it is of May June 18, and the variant is question paper 2. Right. So let's begin with the first question. Our first question is part A. Define force. Okay. So there are two ways to go about this. Obviously, the first formula that comes to your mind when you listen to force is the one that we've been studying throughout O levels, that is F is equals to ma. But what the examiner introduces to you in as an A-level physics student and wants you to grip at over here is delta P over T. What is P? P is the momentum, T is your time. So for using this second formula, we get force is the rate of change of momentum. Full stop. Okay, so one thing that I wanted to emphasize over here is that why do we use the word rate? Because if we compare momentum, we know where does it come from. It's here. Change, we know. Where is the change? The delta. The delta tells you the change. Delta is the Greek symbol for change. So you have change and momentum. Why use rate and where goes time? Basically, whenever you want to emphasize the fact that a quantity is per unit time, you can use the word rate. So consider rate as the alternate word for per unit time. For example, if I give you the example of velocity, why do we say that velocity is the rate of change of displacement? We could have said that it is the change in displacement per unit time according to the formula, because something over t means it's per unit t, right? So whenever we have to change or not use the word per unit time, we bring in rate. Rate and per unit time are interchangeable. So if you don't want to use rate, you would have to use per unit time. Okay? But I would suggest using rate. It's shorter. Why do you need to write the whole 3 words? Just write rate. Force is the rate of change of momentum. Okay. SI units. Okay. For SI units, remember whether you have to calculate it in a single line or they want you to do the entire working. As you can see, it's in part C. Your first step should always be to write the formula with the quantities, and if you can, with the SI quantities, the base quantities, right? So we get force is equals to, now we have two formulas, MA, or you can use, let me use another method. Force is equals to MA, or you can get force is equals to delta P over T, the one we've studied in part A. Now the thing with calculating base units is that whether you use the first formula, whether you use the second formula, if there has been a third formula, you can use the third formula, fourth formula. You will always get the same units as your answer, the same base units as your answer, as long as you plug in the correct values, okay, and you carry out the calculation correctly. I can use this formula or I can use this formula, I will still get the same units. Just for your understanding, I'm going to use both of them and show you, okay? So the first step, remember, plug in the base quantities. So force is equals to mass. Mass is a base quantity, leave it as it is. Acceleration. Acceleration is not a base quantity. It can be written as V over T, right? Now the thing is, V is further not a base quantity. V is S over T, and we already have a T in denominator, so it gets multiplied. What do we have here? If you practice with time, this gets so much easier as long as it's on your fingertips. But till then, if you're just starting doing these calculations, doing these units questions, I would suggest take it slowly. It's good if you spend an extra 3 to 4 seconds, an extra 30 seconds, 20 seconds on doing a question rather than losing those 2 to 3 marks. because even a single mark can affect your grade. So meters, this is mass, this is displacement, and this was our velocity. Now acceleration is velocity over time, this is your displacement over time. We already had a t in a denominator, and that t gets here. So over t square. And this over t square is entirely over. Okay. Now plug in the units. Your second step is plugging in the units. For mass, you have kilogram. I'm again emphasizing this is mass, not meters. For displacement, you have meters. For time square, you have second square. Everything needs to be in the denominator. Oh, sorry, my bad. Everything needs to be in the numerator. So kilograms, meters, second square. This is your answer. Now let's check if we get the same answer from the second formula. So your second formula is F is equals to momentum. Okay, momentum is not a base quantity. The formula for momentum is mass into velocity over time. Again, velocity is again not a base quantity. Velocity is displacement over time. We already have a t here, and here goes your formula. Can you see? They're the same. I can do the entire working for you, but if the formula is same, you're going to get the same in it. So you have mass into displacement over time square. Mass has the unit kilogram, displacement has the unit meters, time has the unit second, time square means second squared. So your force overall has units kilogram, meter. Everything needs to be in the numerator. Again, I was going to say denominator. No. Everything needs to be in the numerator. And here you have your answer. Good. So your answer for part B is kilogram per meter, no, not per meter, kilogram into meter into second square. Okay. Remember, the best thing I can suggest to you while calculating units is remember to plug in base quantities. Take the formula into the base quantities. After that, it's just plugging in the units, right? I would personally suggest don't work with derived quantities, because you people tend to make silly mistakes over there by forgetting the formulas, by mixing up the formulas. So take it into the base quantities. After that, you can even mentally plug in units. Again, I won't suggest doing that, but if you want to, if you think you don't have time, or you're short of time, or you think you're well versed in these questions, go ahead. But writing everything down makes it simpler. Spending another 5 to 6 seconds won't do you much harm, right? Okay. So the next question says, what does it say? The force F between 2 points. So you have a force F between 2 point charges is given by this formula. Okay, so we have this formula, and this is our force, where Q1 and Q2 are the charges. So you have two charges, Q1 and Q2 charges. Right. This has been noted. R is the distance. Please focus on these terms. Please read the question carefully. Please read the question carefully. No silly mistakes, you all. Okay. R is the distance between the charges, and E is the constant that depends on the medium between the charges. E is a constant. Okay. Use the above expression to determine the base units of E. Okay. So we need the base units of E, right? And E is currently not in the numerator. Basically, it's not even in the numerator, and for any quantity whose units we are calculating, we need it to be the subject. So let's make E the subject. First, you have F is equals to Q1, you have Q2, then you have a nice line, and then you have 4 pi r square. Be very careful of the powers, because they tend to be written wrong, and then you tend to get the wrong answer. So you have E is equals to Q1, Q2 over 4 pi r square F. So basically, I just interchanged E and F. Why? Because you have 1 over here, you cross multiply, then you have Q1 over Q2 is equals to F 4 pi r square E, then you need to keep E over here and take the remaining thing below Q1, Q2. So I just ate up a step over here. You can cross multiply having 1 over here and we'll get the same answer. We basically need either subject. Okay. Now, Q was a charge. Remember our first step. Our first step is always to convert these derived quantities into the base quantities. So Q is a charge. We know that Q is equals to I T. I is current, T is seconds. T is time. So Q I. 4 is a constant, pi is a constant, they have constant values and they themselves do not have any units. So writing them in a formula that is primarily being used to derive units, waste of time. Don't write constants, please. Remove constants, r square. So r square, r is the distance. We know r is the distance, so r will have a unit of meters. The SI unit for distance is meters. F is force. You can write F as m over ma and then convert a into s over t, but if we think carefully, we just calculated the units for force after a lot of calculation. So why do we need to waste time over here? We'll just write F and then directly plug in the SI units because we just calculated the SI units for force. Even if we leave out not writing the base quantities for force, it's okay. Now, current is a base quantity, time is a base quantity, distance R is a base quantity, force, we know the base units, so that's okay. Now, we will be plugging in the units. We have our base quantities. For force, we already have the base units. So now, for the rest of them, plugging in the units. Okay. Current into time. Current has the base unit ampere. Time has the base unit seconds. Into ampere seconds. R is the distance, meters, squared, squared. Force, we already know the base units, kilogram, meter, second, minus 2. From part B, we've already done this. Right. Now, let's first simplify. We have meter cube, kilogram, second, minus 2. Next step. Remember, everything has to be in the numerator. Let's bring everything into the numerator. So we have ampere square, second square, meter minus Q3, bringing the power or bringing the quantity from the numerator into the denominator or the denominator into the numerator will change the charge on the power. Will change basically the sign on the power. So if it's positive, it becomes negative. If it's negative, it becomes positive. Meter had a positive Q. Bringing it from the denominator into the numerator makes it a negative 3. Similarly, seconds, let's do kilograms first. Kilogram had a positive 1, which will now become a negative 1. Second had a minus 2 in the denominator. Bringing it in the numerator turns it into positive 2. So at the end of the day, you have ampere square, second square, plus 2, combining these two, kilogram minus 1, meter minus 3. Ampere square, second 4, seconds raised to power 4, kilograms raised to power minus 1, meter raised to power minus 3, and this is your final answer. We'll go back, and this is also what you will be plugging in into your blank. You have ampere square, seconds raised to power 4, kilograms raised to power minus 1, meters raised to power minus 3. Good. Oh yes, we are done with our first question. Let's move on. State the principle of conservation of momentum. Right. So, principle of conservation of momentum states that total momentum Total momentum of all the bodies before collision is equal to total momentum of all the bodies after collision. In other words, you can say that your total momentum is conserved, right? You can also phrase it as total momentum of all the bodies before and after collision is conserved. Let's move on. A stationary firework explodes into three different fragments that move in a horizontal plane, right? So we have a firework and it's exploding into three different fragments, and those three fragments are in horizontal plane, above the plane, below the plane. The fragment of mass 3m has a velocity of 7 meters per second. So you have this fragment of 3m, we don't know what m is, and it's moving with a velocity of 7 meters per second. The second fragment with a mass of 2m has a velocity of 6. And the third fragment with a mass of 1.5 m has a velocity of 8 and at an angle of theta. Okay. Use the principle of conservation of momentum to determine theta. Right. Okay. So, basically, when we see the forces, not horizontal or vertical, they're at angles. So, the first thing that must click into our mind, write their horizontal and vertical component. Basically, resolve them into their horizontal and vertical component. So the idea over here is that we will be resolving the momentum of this 2m and the momentum of 1.5m into its horizontal and vertical components, and then we will be using those components to find theta. So let's resolve them first. Okay, let's start with the vertical components. So vertical component, you have 8 sine, and your angle is theta. And then you have the other vertical component, 6 sine theta. Right. Next, you have your horizontal component in this direction, 6 cos theta. And then you have your other horizontal component in this direction, 8 cos theta. Now the thing is that we have to make a comparison, right? We are resolving the momentums when we have to compare the momentum of 2m and 1.5m with 3m. 3m has only a vertical component. It's straight, it's perpendicular to the plane. So what components will we be using here? Vertical ones. If 3m was at an angle and it had horizontal and vertical components both, then it was our choice. We could have used either horizontal or vertical. Since the comparison has to be between 3m, which is above the plane, and 2m and 1.5m, which are below the plane, we need to utilize their vertical components only, because this only has vertical components. Sorry, can't do anything. Okay. Resolving them into their vertical components, what we're going to do is, seven is our speed, and then you have 3.0 m. We don't know what m is, but we cannot exclude m because they have not told us if it's a unit or anything else. So currently m is a constant, a value that is with 3, right? So this entire 3m is the mass. Now the other side we have the vertical components. Let's start with the first one, 6 sine theta into, we have 2m, and this will be added to 8 sine theta with a mass of 1.5 m. Moving on, we have 21 m is equals to 24 sine theta m. Right? Let's keep sine theta on one side and take everything else on the other. So sine theta remains as it is, 21m over 24m. M and m are cancelled because they're the same thing, whether it's a constant or any other value, it's same. So you have now, making theta your subject, you will get theta is equals to sine inverse of 21 over 24. Theta will be equal to, rounded off to actually 61 degrees. So this is your answer. Right. So this is what you will be plugging in. 61 degrees. Why rounded off to? Oh no, no degrees. You have the degree sign. So your answer is 61. Right. Why did we give it to many people? And when I was a student, I had this question: why two significant figures? Why not three? Why not four? Because we're rounding it off, right? We rounded off to two because the question has two. You have to look at your question, and in physics, it's not unanimously followed in the entire paper. Okay, if it's the first question has two significant figures, you have to answer all the entire questions in two. No, you have to check this in every question that you are answering. If you're doing question 2 and it is giving maximum to two significant figures, you have to give your answer for that question in two significant figures. If my question 3 has given to four significant figures, then I have the option to give it till 4, right? So you have to see the question you are doing at that moment. However, within that question, yes, in the entire question 2, I have to give it till two significant figures. Let's move on. So we have done the first part. Okay, what is the second one saying? Calculate the ratio of kinetic energy of fragment of mass 2m and kinetic energy of fragment of mass 1.5m. So we do know, since we are very intelligent people, that kinetic energy is equals to 1 over 2 mv square. And this is what we're going to use here. So our ratio will basically be, so I'm directly plugging in the values, but this is the formula that I will be using. So kinetic energy of fragment of mass 2m. So let's do that. 1 over 2 m. So mass 2m, it has a mass of 2.0 m. And the speed of this fragment was, 2m has a speed of 6. So we will be writing 6 square over the kinetic formula for kinetic energy for this 1.5 m fragment with a speed, it had a speed of 8 square. So my favorite thing to do, let's cancel, cancel, cancel and cancel. What we left with, we have a 2 multiplied by a 6 square divided by 1.5 and multiplied by an 8 square. Right. And then on further solving is equals to 0.75. Ratios do not have any units. Don't get confused. Don't worry. A ratio will never have a unit and you can check. There is no unit. So your answer is 0.75 and that is right. Let's move on. Okay. So we're done with question 2 as well. It was an easy. It wasn't easy, but it was relatively easy. It was a bit lengthy, but easy to work out and short. It's okay. Okay, so question number 3 tells you a child on a sledge slides down a deep, steep hill and then travels in a straight line up an ice-covered slope. So the child came like this and now he's traveling up the slope. The child, remember, the child has a total mass, okay, no, child and sledge have a total mass of 70 kg. So this entire thing with the child and the sledge will have a mass is equals to 7. Right. Moving up the slope with a speed 18, I guess. The sledge passes point A, right? So let me highlight point A. This is B. And let's use green. Oh. What do we do? All right. Okay. So this is A and this is B. So he's passing point A with a speed 18. Okay, so point A, you have a speed of 18 at time t is equals to 0. Very important. So at A, your time is 0. Okay. Then comes to rest. Then he will be coming to rest at point B. What does rest mean? Rest means that the speed of the child and the sledge at point B will be 0. The child applies a brake to the sledge at point B. Okay, so now he's traveling and at B he decides, let's apply a brake. The brake does not keep the sledge stationary and it immediately slides back down the slope towards A. Okay. So basically what is happening here is the child is traveling. We're not concerned with this, the last part of the journey. What we're concerned with is from he's traveling from A to B. He goes till B. Then he applies brakes. So at B, he suddenly thinks, wow, let's apply brakes. So he applies brakes. This is your first part of the journey. He will apply his brakes and then they say that instead of immediately stopping, he starts to come back for a little while. So this is after applying brakes, your second part of the journey. Right. Okay, so let's see what is he asking us. Okay, so he's not given us what time was it at B. The only thing we know is that velocity will be 0 at B and time will be 0 at A. And velocity at 18 at A. The variation with time t of the velocity v of the sledge from t is equals to 0 to t is equals to 24 seconds is shown in figure 3.2. Okay, so before we read the question, let's just use what we have derived from this information and start plugging it in. We know that the point where your speed is 18 and your time is 0 is point A. So this is your point A. We know that the place where your velocity is 0 is point B. So this where your your velocity, yes, your y-axis, yes. So this is, and we also figured out that he will apply brakes at B. So we can say, let me use a line that this is the first. Let me use a line. Right. So this is basically your first part of the journey. That is, he will be applying brakes. This is your before brakes part. And then he tells us that at B he applies brakes. So at B he will be applying brakes. So this is your second part, the part that we said that it was the second part or after. I can call it after brakes. Right. So we have all the information over here, and we can even see for how much time did he keep on moving backwards. So that's basically till time is equals to 24 seconds. Okay. Now let's see what is he asking us actually. State the time taken for the sledge to travel from A to B. Oh, that's easy. From A to B, he took 12 seconds. That was easy. So the time is 12 seconds. Next part. Determine the displacement of the sledge up the slope from point A at time t is equals to 24 seconds. So from point A till t is equals to 24 seconds, we need to figure out the displacement. Okay. We can see that this is a velocity time graph, and in a velocity time graph, you can find the displacement by calculating. Let me use a different color. Something that people can see easily. Okay, this is good. So we have to find out the area basically of these two triangles. So the two triangles are this triangle. Most satisfying thing I have done in life is to color triangles. And this triangle, yeah, it was a very lame joke. You don't need to think it in your mind. I know it's a lame joke. Okay, so this triangle. Right, so we need to find the area. Let's do for triangle 1 first, and then we'll move on to triangle 2, and then we will be adding on the areas. So for our first part of the journey, that was before the bricks, when he was going from A to B, this is basically A to B. You have 1/2 area of a triangle base into height. Your base is, let's see what is the base. Your base is 12 till point B, because you are calculating from A to B, and your height is going to be 18, the speed at A. So you have 1/2 18 into 12, and your answer will be 108 meters. Right. So for the second part of the journey, that is from the second part of the journey is from point B to the point that you applied the brakes. Oh, as a child applied the brakes. So point B is it is from the point B where the child applied the brakes till the point that he kept on moving backwards until the point that he has given us in the graph. We have been provided with. So it is basically 1/2 base again into height, because again we have a triangle. 1/2 base is going to be, and height is going to be, let's see what is the base and the height. So your base is basically 12 minus 24, because you have to take this part into account as well. I couldn't color it because I don't want to confuse you people. But yes, so 12 till 24 you have to take the base, and your height is going to be from 0 to, okay, so this is 6, right? Let's do it. You have a base 24 minus 12, and then you have a height 6, and your answer will be 36 meters. Now, using both this information, displacement, now here's the tricky part. Remember, always displacement is a vector quantity. Because displacement is a vector quantity, signs are important. 108 plus minus 36, right? Because it's a vector quantity, we need to take the signs into account. It is going backwards. Your answer will be a positive 72 meters. So you have a positive 72. Okay. So this was how you calculated the displacement for a velocity time graph. Okay, show that the acceleration of the sledge as it moves from B back towards A is 0.5 meters per second square. Okay. So you have to calculate the acceleration, right? And you have the, what do you have? You have the force, you have the velocity. Right. The best thing to work about is here to see that this is a straight line graph. And remember, we know the gradient of a velocity time graph is acceleration. So acceleration is basically the gradient of a velocity time graph. And we also know that by chance over here we have straight lines. Straight lines mean constant acceleration. So you will be calculating gradient of a velocity time graph. Right. So our values will be from B towards A, back towards A. So our values are going to be, for velocity we know it was 6 minus 0, and for time we know it's 24 minus 12. This is going to be 6 over 12 is equals to 0.50 meter second. Where is my yellow? Here you are. Right, so this is your answer. Okay, let's move on. The child and sledge have a total mass, you already know that, we've discussed this, of 70 kg. The component of the total weight of the sledge and that acts, okay, down the slope is 80 newtons. Total mass, component of the total weight, determine, okay. Before we read, what do we have to determine? Well, I've already seen the frictional force all apart. But remember, always remember to draw a diagram. You have to resolve it into its components. So you know it's a slope, and Mr. Child and the sledge are traveling he wants you to consider B towards A. So B towards A is they're moving downwards. So you have your Mr. Child on a sledge and he is moving downwards. B towards A, this is B, this is A. This is the scenario where he has already applied the brakes and now he's eventually going to stop. So your direction of motion is basically this. This is your direction of motion, downwards. Okay. Now they've told us that the weight, which is, this is the weight, the component of the weight that is acting down, this component is 80 newtons. We know from the resolution of weight into its components, let me show you, this is W cos theta and this is W sin theta and this is your theta. Comparing this W sin theta is basically this W sin theta, which they've told us is equals to 80. Right. We also know, okay, this is a frictional surface. There is going to be some friction. So let's draw friction. Here comes Mr. Friction. Always in the opposite direction to the direction of motion. Now, what is he asking us? Frictional force. Okay. He's asking us what is the frictional force that is acting on Mr. Child on his sledge. That's easy. We know that resultant force, my bad, I'll make sure to write resultant because I don't want you people to be roaming about and asking force. How do we subtract force from friction? Resultant force is equals to MA. Resultant force means the main force, the driving force minus the frictional force is equals to MA. Now we plug in the values, main force, the driving force is 80, the frictional force is, we don't know, we have to calculate it. Mass has been told is 70, acceleration we just calculated in the last part is 0.50. We will get a value of F to be 45 newtons. So your frictional force is 45 newtons. Right. Okay. Okay, the angle theta of the slope to the horizontal. Okay. We know, they've already told us that W sine theta, the component of W, the way that is acting downwards is 80, right? 80 newtons, so 80, the magnitude concerned with the magnitude. W means mg, sine theta we have to calculate, 80 we already have. Let's take everything else apart from sine theta on the other side, so you have mg. And now let's take everything except for theta on the other side, so you have theta is equals to sine inverse of 80 over mg. Right, so theta is equals to sine inverse 80. Mass we know 70. Gravity we know 9.81. In physics, in your A levels maths mechanics papers, please use 10, don't use 9.81. Theta will be 6.69 degrees, and since we are doing till two significant figures in this question, rounded off to 6.7 degrees. So your answer is 6.7 degrees. There you go. Right. Let's move on to the next part. The child on the sledge blows a whistle from t is equals to 4 to t is equals to 8 seconds. First of all, let's determine t4 and t8. We know that we basically have to determine beforehand, is it from A to B or B till back to A. So this is A to B. 4 to 8 seconds lies in the first part of the journey. This means that your student on a sledge or your child on a sledge is basically, Mr. Child on the sledge is basically currently from t to 4, t is equals to 4 to 8 seconds, moving towards b, right? So we know that. We are concerned with this section, the first part of the journey. Okay. The whistle emits sound of frequency 900 Hz. Here we go. First of all, we have frequency emitted at 900 Hz. Then he says the speed of the sound in air is 340 meters per second. A man standing at point A hears the sound. That is why I wanted to figure out whether the journey was from A to B or from B back to A. Thing is, he is saying the person is standing at A. So there is this person, Mr. A, he's standing at A and he's seeing this child using the sledge to go up the slope. And this is your sledge and child and he's going up the slope. Now the important thing, because he wants us to determine the initial frequency of the sound heard by the man, we have to basically determine the observed frequency, and for the formula of the observed frequency you need to know your object is moving towards the observer, Mr. A, or away from the observer, Mr. A. In this case, we know t is equals to 4 and 8 seconds lies in the part of the journey that is from A to B. So from 4 seconds to 8 seconds, Mr. Child on the sledge is going to be going upwards, away from point A, away from Mr. A. So your formula should be according to away. What is your formula? The formula for observed frequency says that F observed is equals to the frequency of the source into the velocity of the medium in which we are calculating the frequency. In this case, it is sound in air. So we have to see the velocity of sound in air. Then we have velocity again of sound in which medium? In air, plus or minus velocity of source. Very important, you will use plus when object is moving away from the observer. You will be using a minus Okay. In our situation, in our question, we are concerned with away. So we will be using the plus sign. Right. Let's come back to our question. Frequency observed is equals to frequency of source into velocity of sound in that medium, which is air in this case. Then you have velocity of sound in that medium plus y plus, because it's moving away, velocity of source. Plugging in the values, frequency of source is 900, value of velocity of sound in air is 340, velocity of sound in air is again 340, and velocity of source from t is equals to 4 till t is equals to 8. Okay, so we basically need to go back to the graph. This is 4 and this is 8. This is 12. So we have 12 meters per second. Asha, why did I check t is equals to 4 for the velocity of the source? Because we have initial frequency, that is t is equals to 4 seconds, so 12. your frequency observed will be 869 hertz. So you have the answer 869. Okay. We discussed basically, so what did we do in this question? We know our formula will be frequency observed is equals to frequency of source into velocity of sound in that medium, which in this case was air, divided by velocity of sound in that medium, which in this case was air, that is 340, plus velocity of source if the object is moving away from the observer, and minus the velocity of source if the object is moving towards the observer. Why did I use the value of 12 at t is equals to 4 seconds? Because in the question they have asked us to determine the initial frequency. So for the initial frequency, what I had to do was go back to the graph at the initial time, that is t is equals to 4 seconds, and at the initial time the velocity is 12, right? I plugged in the value, I plugged in the values, and then I got a final answer of 869 hertz, right? Let's move on. Describe and explain qualitatively the variation, if any, in the frequency of the sound heard by the man. Right. We know, basically, we know till here that the person, Mr. A, is standing here, and Mr. Child is constantly moving away from Mr. A towards point B, right? He is on his sledge and he's moving away. He's like, bye-bye. So what is happening to the frequency that is being heard by Mr. A? For this, remember, using this formula, we know that the frequency heard by Mr. Man is 1 over the speed of the child and the sledge. So as they're going upwards, remember at point B the velocity becomes 0, right? We know that at point B, let me show you. We have already seen that at point B, the velocity of Mr. Child and sledge from point A was 18, at point B it becomes 0. This means from a journey from 4 seconds, or if you don't even want to consider 4, you want to, if you don't want to consider B, you want to consider the time span of the journey that he has suggested you in this part, that is 4 seconds to 8 seconds, it is decreasing. So the velocity of Mr. Child on the sledge is constantly decreasing. If the velocity of the source is decreasing, automatically the observed velocity, that is the the observed frequency, the frequency of the sound heard by Mr. A will obviously decrease. So you have to state it. Velocity of child and sledge, Vs, decreases So observed frequency FO Right, so this was our question number 3. Let's move on. Define the wavelength of a progressive wave. So that's the definition, to the point. Right, so what is the wavelength of a progressive wave? The distance between two consecutive in-phase particles of a moving wave. Next part. State what is meant by an antinode of a stationary wave. So an antinode is basically the position on a stationary wave There you go. So basically, your antinode of a stationary wave is the position on a stationary wave with maximum amplitude. Okay. The loudspeaker producing sound of constant frequency is placed near the open end of a pipe. So you have a loudspeaker and you have open end of a pipe and okay. I have an important part. Okay. The speed is 0.75. Let's see what is he saying. A movable piston is at a distance x from the open end of the pipe. Okay. Distance x is increased from x is equals to 0, probably from here till here. By moving the piston to the left with a constant speed of 0.75. So he moved the piston from this point to this point with a speed of 0.75. The speed of the sound in the pipe is 340. Right, you are. A much louder sound is first heard when x is 4.5 centimeters. Assume there is an antinode of a stationary wave at the open end of the pipe. Determine the frequency of the sound in the pipe. Basically, what he's saying over here is, let me draw a diagram for you. He's saying that we have an antinode. Antinode means that your wave has to have a node over here. That is the reason why that he heard a loud sound, node and antinode. And because the distance between a node and an antinode, and he also told you that this is 4.5 centimeters. This is what he has told you. What he's asking you is that you have to determine the frequency of sound. The speed of sound is 340, right? He wants you to find the frequency. For the frequency of sound, you need to find the wavelength. We will first find the wavelength using this. How? We know that displacement, the distance between a node and an antinode is pi by 4. So pi by 4 is 4.5 centimeters. This means that your wavelength is 4 into 4.5 is equals to 18 centimeters. This is your first part. The second part is calculating frequency. Speed is equals to frequency into wavelength. Therefore, frequency is equals to speed over wavelength. What is the speed? 340 meters per second. Since they're considering meters, we have to take 18 centimeters into meters. That is 0.18. And your frequency will be 1.89 into 10 raised to power 3 hertz. So this is your frequency. Right. Let's move on. After a time interval, so some time passes, a second much louder sound is heard. Okay. Calculate the time interval between the first louder sound and the second louder sound being heard. He tells you that some time passes. You have an antinode, then you have a node, then some time passes, and then you hear another loud sound. Basically, you should have reached another node or an antinode. So you have a node, and then you have an antinode. We will now be using this formation. We know that the distance between two consecutive nodes or two consecutive antinodes will always be put equal to pi by 2. So pi by 2 we know we've calculated is 18 centimeters. Oh, my bad. So sorry. Pi by 2 is what we have to calculate. Pi we know is 18 centimeters. So automatically pi by 2 is going to be 9 centimeters. Using this information that pi by 2 is 9 centimeters, we have to find the time interval. So using the formula V is equals to S over T, S is 9 into 10 minus 2. We have to find time. Okay, T we don't know and V is 340. T is going to be 340. Oh, no 340. You are going to have 9 into 10 minus 2 over 340. Time is going to be Okay. Okay. I think I've done something incorrect. Calculate time to send the sound between being heard. Right. You will not be taking 340 over here. The speed of the sound that you are going to take is 0.75. Why? Because in the previous question, we were concerned with the frequency of the sound. That is why we took the speed of the sound. In this case, we are concerned with the speed at which he is moving the, what is it he's moving? The piston, the movable piston. So you will be taking 0.75 as the speed. This was important. I didn't make a mistake over here. So this is 12 seconds. Right. Remember, you have to take the speed at which we are moving the piston, not the speed of sound over here. Because it is the speed at which we move the piston that we reach another antinode and we hear the second louder sound. That is why we have to consider the speed at which we move the piston. Because the speed at which we move it is basically the factor that is determining when we'll be hearing the second loud sound. So this is your question number 4. Let's move on to question number 5. Right. A solid cylinder is lifted out of oil by a wire attached to a motor. So it's going up. Shows two different positions, x and y, of the cylinder during the lifting process. So you have a velocity 0.02, cylinder at position x, cylinder at position y. It's going to be lifted up. Okay. The motor is fixed to an overhead beam. This is your beam. The cylinder has cross-sectional area of 0.018, length 1.2, weight 560, and density of oil is 940 kg per meter cube. Throughout the lifting process, the cylinder moves vertically upwards with a constant velocity of 0.02. Okay, the viscous force of the oil acting on the cylinder is negligible. Before we move on, let's just write everything that they've given us. So it's easier for us to work out. 1.2, weight is equals to 560, density is equals to 940. Everything is in their base correct SI units, right? And then your velocity 0.20. Okay. Calculate the density of the cylinder. So we have to calculate the density, and we have been given these quantities. So we know that density is equals to mass over volume. We don't have mass, however we do have weight. So density is equals to weight over grams. Volume, we don't have the volume directly given, but we do have area into length, and volume is equals to area into length. So this becomes density is equals to weight divided by your gravitational force, into area into length. Density is equals to weight is equals to mg. M over here is we don't know, right? So we don't have. So right, we have to use the weight directly. 560 over 9.81. This is your mass. Then you have area. For area, we have 0.018, and then you have length 1. So your density will have a value of 2.264 2.8059 kilograms meter cube, and this will be rounded off 2.64 into 10 minus. Right, I just want to check one thing. Just give me a minute. Yes, exactly. I was correct. You have to round it off to two significant figures. Let me just correct it for you. So this rounding off to two significant figures, 2600 kilograms per meter cube. Why two significant figures? Because the question only deals with two significant figures. Okay, moving on. For the cylinder at position X, show that the upthrust due to the oil is 200 newtons. So upthrust is equals to force 1 minus force 2. Force can also be written as pressure into area. Therefore, we know upthrust is equals to pressure 1 area 1 minus pressure 2. Area 2, we are dealing with the same area, so this becomes pressure 1 minus pressure 2 into the same area. Pressure can also be written as rho G delta A. So delta P, so we know delta P into A is equals to rho G delta H into A. Now, plugging in the values, we have 1.2, 9.81, 940 and 0.018 is equals to, your upthrust will be equal to 199 newtons. Rounding it off to two significant figures, you have 200 newtons. That's it. Now let's move on. Calculate for the moving cylinder at position X the tension in the wire. Okay. We know that tension and upthrust are the upward forces and the weight will be the downward acting force. So, tension is basically equal to weight minus upthrust. You have tension is equals to 560. Weight is given in the question. We calculated the upthrust just now. So, tension is equals to 360. Right. The power output. Okay. So for the power output, we know power is equals to force into velocity. Force we have 361. Velocity we have 0.020. Power will be 7.22 watts, rounded off to 7.2 watts. Okay. So this is your C part. Moving on to the D part. The cylinder is raised with constant velocity from position X to position Y. State and explain the variation, if any, of the power output of the motor as the cylinder is raised. Numerical values are not required. Okay. So the important thing that you have to understand for this part is that upthrust plus tension is equals to weight. You cannot basically change the weight. The weight of the cylinder is a constant, right? Right. So the weight of the cylinder is a constant. You cannot change that. However, when you're raising the cylinder, the upthrust will constantly decrease. This is going to decrease. What is going to happen to tension? That is the question. Basically, weight is constant. We cannot change weight. This quantity is constantly decreasing and there is an is equals to sign in between, which must be obeyed. This means both quantities must be equal. To keep the two quantities equal, if this is decreasing, we have to automatically start increasing tension. Why? So that if one decreases, the others increase, balances this part of the equation. The other is a constant and both of them can still be put equal. Using this logic, we will be answering our question. This is the first part. Now, the question asks you what happens to the power. Remember, we use the tension as force in power is equals to Fv, right? So if tension is the force over here and I start increasing the force, power and force are directly proportional. So my power output will also start to increase. Okay, so that was this question. Next part. The rate of energy output of the motor is less than the rate of increase of gravitational potential energy of the cylinder. Without calculation, explain this difference. Easy. Sum of the work right, and this was our question number 5. So now let's move on to question number 6. State Kirchhoff's first law. Okay. Kirchhoff's first law states that is equal to, let me continue it on this side. This is Kirchhoff's first law. So Kirchhoff's first law states that the algebraic sum of all currents entering a junction is basically equal to the algebraic sum of all currents leaving the junction. Right. Kirchhoff's first law is linked to the conservation of a certain quantity. State this quantity. Charge. Second law is related to the conservation of current. First law is related to the conservation of charge. A battery of electromotive force 8 volts and internal resistance 2 ohms is connected to a resistor X and wire Y. So you have a X, you have a Y. 8 volts is the EMF and 2 ohms is the internal resistance. 2.5 amperes is the current. 15 ohms is the resistance of X. Okay. So the resistance of X is 15 ohms and the resistance of Y is RY. The current in the battery is 2.5 amperes. So let's just write down everything we have. Rx is basically 15. Current in the entire thing, because it's in series, so the current in the entire thing is 2.5, but in these different junctions it will be different. So that we will be having to find out. 2.5 amperes. And resistance of Y he has not given us. R he has told us and E he has told us, which was 2 and 8. Okay. The thermal energy dissipated in the battery in a time of 5 minutes. Okay, so that's easy. E is equals to I square R T. You have I 2.5 square. R is 2 and T is 5 minutes. It has to be in seconds, so we multiply by 60. Your answer will be 3.75 into 10 raised to power 3 joules, because we have to give our answers in two significant figures. It will be 3.8, 10, 3 joules. Right, let's move on. The terminal potential difference of the battery. So the terminal potential difference of the battery, we know that EMF is equals to V plus terminal potential difference. Potential difference is basically E minus internal potential difference. So your answer will be 3 volts. Okay, let's move on. Determine the resistance R by. Okay, the resistance R Y. So we have the resistance of X, and we have the entire current, and then we have the voltage. Okay, so let's use Kirchhoff's first law. The first step here is to determine the current through X. So Ix is equals to, since it's a series connection, so voltage into the entire circuit is the same. So that remains the same, but the resistance is different. So you have Ix is basically equal to 3 over 15, and this will give you 0.20 ampere. The second step is, by Kirchhoff's law, we know that Ix plus Iy is equals to total current. Remember that Kirchhoff's law states that the algebraic sum of all the currents entering the junction is same as the algebraic sum of all the currents leaving the junction. The algebraic sum of all the currents leaving is 2.5. They've given us. We've calculated Ix. Now we can find Iy. So Iy is basically 2.5 amperes minus 0.20 amperes, and that gives us 2.3 amperes. Right. A third part is that by Ohm's law, we know that V is equals to IR. Since it's a series circuit, V remains the same throughout the circuit. Iy we have calculated, so therefore Ry is equals to 3.0 over 2.3. So Ry is equals to 1.30 ohms. This is your answer. Right. Let's move on. A new wire Z has the same length but less resistance than wire Y. Okay. So what this tell you is that we have Z and you have Y. This is a new wire. Z has the same length, so both have the same length, but Z has less resistance than wire Y. So if this is R, Z will be lower resistance than R. ठीक है. State two possible differences between wire Z and wire Y that would separately cause wire Z to have less resistance than wire Y. Now we have to basically look for a formula that relates length, resistance, and some other quantities which we can create a proportion with. So the basic formula is resistivity into length over A. Length, they've told us, is constant, so we cannot compare it with length. The other two quantities, however, they've not mentioned, so we can compare it. Resistance is directly proportional to resistivity. If wire Z has a less resistance than wire Y, therefore, because resistance and resistivity are proportional, the resistivity of wire Z will also be lesser than that of Y, right? Then we also know that resistance is inversely proportional to cross-sectional area. Therefore, if Z has a lesser resistance than wire Y, Z will also have a higher cross-sectional area than wire Y. Why? Because resistance and cross-sectional area are inversely proportional. We will be using these two differences. Okay, so to phrase it, let's go. Right. So this is our first part to the third part. Now, the last part tells you why Y is replaced in the circuit by wire Z. Okay. By considering the current in the battery, state and explain the effect of changing the wires on the total power produced by the battery. So, we basically know that R is inversely proportional to current from V is equals to IR. And Y had a higher resistance replaced by Z. Z has a lower resistance. So, if we are decreasing R, overall current will increase. And current in itself is related to power in P is equals to VI. So if I am increasing the current, power will also increase. So the power output, in short, is going to increase. Now to phrase it properly, we have so the power is going to increase, resistance decreases. Why? Because resistance is because Y is replaced by Z, Z had a lower resistance. Lower resistance means current increases. Current increases means power increases. Right. Let's move on. Okay, so this is basically, I guess, the last question. In the above equation, okay, so let's read it from the start. A stationary nucleus X decays to form nucleus Y as shown in the equation. In the above equation, draw a circle around all symbols that represent a lepton. So, yes, your electron is a lepton. Your anti-neutrino is an electron. State the name of the particles that particle represented by the symbol V. Okay, so this is an electron, anti-neutrino. Energy is released during the decay process. State the form of energy that is gained by nucleus Y. Kinetic. This is easy. Kinetic energy is released. People remember. Okay. By comparing the compositions of X and Y, state and explain whether they are isotopes. Okay, basically, so what you need to understand is that the mass number and the mass number is together on this side. Both sides of the equation should be equal, and the proton numbers on both sides should be equal. Now, the thing is, if we start to plug in, let me copy this equation on this side so I can first explain you, because the important thing is that you understand what you're doing. So focus, always remember, focus on the quality of the papers that you're solving for practice. Quality is more important than quantity. If you're just focusing from the marks scheme and just trying to solve as many as you can, it won't help that much if you're able to solve a few, but with great concentration on the concepts that have been covered, right? Okay. So what he's telling us basically is, or what I am telling you basically is that the mass numbers on both sides and the proton numbers must be equal. Now your neutrino has 0 and 0, so let's just leave it out. An electron has -1 and 0, and then you have x and y. Basically, y -1 should be equal to a. This means that your proton number for y should be 1 greater than a. Like for example, if y is 20, so a must be 19 because 1 is going to be subtracted from y. So your y will always be 1 greater than a by 1. Let's come to the mass numbers. Your mass number will be having one more electron. Basically, y will be having one more electron. Why? Because you have an y will be having one more neutron. Why? Because you have one more electron anti-neutrino. Since your mass number is changing, we could have said, okay, maybe x and y are isotopes. But because your y and a are not the same, they cannot be isotopes. Why? Because if you remember the definition for isotopes, it is basically that these atoms have the same atomic number but different nucleon numbers. In the case of x and y, they have different mass numbers or nucleon numbers, and they also have different atomic numbers, and isotopes must have the same atomic numbers. So your answer will be okay. Why does it have one less neutron? Because it has an electron anti-neutrino alongside it, so it will have one less neutron. This is only right. The only thing that it has is one neutron. It is a neutron. Less neutron than X. Here you are. Now the last part of the paper, the quark composition of one nucleon is NX is changed during the emission of a beta negative particle. Yes, we've just discussed it. Can neutron changes to a proton? So what is describe the change to the quark composition? It is basically neutron that is an up down changes to up down. And this is the end of the paper. If you people have any questions regarding any question that we just solved or any concept that you want to discuss, you can let me know in the comment section. In case you want me to do a chapter or a lecture exercise or a lecture video on any of the chapters in A-level physics, you can let me know that as well. I will do it and upload it. I'll try my best. If you want me to solve any other paper, you can let me know that as well. I hope I was clear in most of the concepts. In any way, if you were not able to understand me or you still have a question regarding how this so and so was done, you can just type in whatever question you have in the comment section and you can let me know. Okay, Allah Hafiz people, and thank you for watching, and remember to like and subscribe, and bye. Allah Hafiz.